Hey guys, it's Doc, and this is one of the first tech videos we're doing on the new wave mat that we have launching for 2019. By the time you watch this video, I think both mats might be available for sale on the website. I'm not sure yet. So hold on, we'll get right to it. Hey guys, this is going to be an interesting video because I've got to squeeze 5 to 10 hours of technical testing, scientific data, and get it into 20 minutes. So I don't know how the heck I'm going to do this. And the best way for me to do this is just to grab a beer, or since it's 9 o'clock in the morning, grab a coffee, and let's just talk about this. Let's have a chat. I'm going to try and not get too technical about this, but there's a lot that not only we're learning about this mat, but you have to learn about this mat, and you need to watch this video. If you're going to purchase a wave mat, I can't repeat this. Bear with me here for a minute and learn some of this science and learn some of this technology, because it is fairly new. So I'm going to go over several different subjects, and then I'm going to take you out to, yesterday we were at the warehouse and we shot some of our, a little bit of controlled testing and testing different GPHs and different pitches and different stuff. But I'm going to start by going through just a couple bullet points on what the mat is, how it evolved, and how you can use this and how we plan to use it. Now remember, there's two mats. I'm going to say that up front. There's two mats. There's the standard wave mat, which is for lower flows and softer sluices, and then there's the big wave mat. The big wave mat really is used in combination with another mat. So if you were to use it, you would use something like UR or Motherload, a smooth mat, and then put a big wave. Now, the wave mat is you can use all by itself because it has a lot of open area with a hump inside of it. So there's two different mats. The wave mat is for lower velocity, lower energy, lower GPH sluices, where your water is, you know, 1/2 inch to 3/4 of an inch, a smooth, sort of like if you look at our Raptor flare, that flare out section, or in a super hog, something like that, an area where the water is smooth and shallow, that's where you want to run this. But we did find out that yesterday that we could bump up the water flow just a little bit. The big wave mat, you really need to use that in combination with something. You can use that in just about, commercial ops can use that. Yes, you can put it in dredges, but dredges are short. And I really stress that I don't consider the wave mat a primary capture mat. The reason and design for this mat is twofold. Number one, we really wanted to, it started with a development sort of on beach sands, because a lot of guys run beach sands, whether they're in Alaska, whether they're in Washington, wherever they are, and they run beach sands. There's crushing operations that have really fine crush that need a more open mat that has a different process other than riffles and flow interruptions. So that's where this wave mat came in. I don't consider it a primary capture mat. If you're going to have a sluice, you're going to have a sluice with traditional riffles or something more aggressive like our other mattings, like the Talon mat, scrubber mat, river hog, trimmed river hog mat. You need to, your slurry, if you have a 36-inch long sluice, your slurry only has about 2 to 3 seconds. Boom, and it's gone. So you need to be aggressive with it. Where this mat comes into play is what's in those tailings. No sluice, I don't care what it is, runs 100%. I don't care if it's 99.5% capture rate, but no sluice runs 100%, and that's where this comes into play. We wanted a mat that we could put on our tailings or use on different materials that had a different flow and exchange. So let's talk about real quick how I came up with this. I've been working on this and had this concept in my mind for close to 3 years now, and it has to do more so with the water flow and reduction and different changes in water speed and slurry speed and velocities and settling velocities and a few different dynamics that are involved in that. And we actually started putting pieces of wood or dowel under our mats to sort of create that. That's how we initially did it. Then we went to our flow model testing. We did our flow model testing, and then we just got in the actual matting to where we could get all the actual true controlled testing data done on it. But really, for 3 years, we've been looking at this, and we've been looking at it at sort of a small scale, watching what happens in our mats and our patterns. And that's where we sort of pulled it from, and then we expanded up into a larger scale. So number one, I want to talk about our patent. I couldn't talk about this over the past year because we were applying for a utility patent. We don't have a design patent, we have a utility patent, and it's on the actual process of this. And the process being a hump, a convex shape, some type of bulge inside of a gold sluice that through the use of manipulation of velocities and water speeds allows heavy materials to drop out. So that's what it's for. So it's not, we don't have a patent just on our sluice mat. We can actually take this design and actually form sluices that actually have this shape as well too. That's going to be a little more difficult to do. We might integrate that later, but that's what our patent covers. Our patent covers that wave shape inside of a sluice mat, or any gold capture device. That's what the patent covers. And let me explain sort of how this works. If I take a baseball and I'm up in space and I take a baseball and I throw a baseball, I have put energy on that baseball. That baseball will continue for 1,000,000 years at that same speed and that same line because there's no fluid and there's no air and there's no gravity in space. Well, on Earth, it's different. On Earth, we have gravity, we have fluid, we have air, we have different forces. So as that baseball is traveling through, there's gravity pushing down on it, and there's also flow that's slowing it down. And that's really where we come in. It's not only its terminal velocity, it's settling velocity. There's a bunch of different things involved with that. It's another example, if you're on the moon and you take a bowling ball and a feather and you drop it, guess what? They're both going to hit the ground at the same time. You come to Earth, and because there's air, fluid, the feather is going to go slowly down to the ground, and the bowling ball is going to go faster because there's forces pushing up against that. And that's really what we're looking into when we work in this mat, is how do we use those and manipulate those forces to separate out the slurry that's running through your sluice. So I want you to also think about this. You have a river that's running straight down, and it's really raging down there, and everything's going through. All the gold is moving down it, nothing is staying. Well, that river hits a bend, and what happens? Well, the water has to slow down around that bend, and what drops out? The gold drops out as the water slows down because the energy drops. And so the gold has a chance to drop out there. That's why you want to see on inside bends, you're going to see gold drop out, and areas where water slows, where rivers fan out, alluvial fans, different areas where energy changes, gold can drop out. And that's what we're doing in this. We're using the change of energy and water speed to allow the material to drop out without the use of flow interruption. And I put that, if you go to the website, you'll see that all through there. This mat is one of the first mats to actually just use the manipulation of water speed and velocities and energies and not use flow interruption. So let's talk about flow interruption real quick. Traditionally, you have water traveling down a slurry, you put in a riffle. The water hits the riffle, it has to go up over that riffle, and then there's a vortex behind here. It's a low pressure zone. So as the slurry hits this, goes up over, things can come into this low pressure or low energy zone and build up back here, and then it goes on. Here's the problem. Now, our mats, we use that same technology in almost all of our mats, but we do it on a much smaller scale. And that's why they work a little bit better, especially even in dredges. But here's the problem with that. You have 3 layers in your slurry. You have a bed load, you have a sediment load, and you have a dissolve load. The bed load is everything that's heavy, gold and black sands, and everything that's heavy is down here. It's settling. It quickly settles and goes down to the bed load. Here is your sediment load. Your sediment load is trying to settle down into this bed load as well too. And a lot of times superfine gold will be in the sediment load or will be in the bed load. And then you have your dissolve load. Dissolve load is typically stuff like silts and clays. That's why your water stays dirty, because it's the dissolve load. It would take hours for this to settle down here. You'd have to put it in a jar and let it slowly settle. So those are your three loads. Well, when those three loads, gold is trying to drop out of this middle load here and settle into the bed load. When those three loads hit this ramp, what has to happen? All three loads now get thrown back up into the turbulence and the energy of that sluice in that water. So now you have three loads that are actually classifying and stratifying the material. Gold is falling down, it hits this riffle and it has to go back up, and there's turbulence and the fine gold gets thrown back in. So that's kind of how riffles work, but they're also kind of why they're sometimes not that good. There is a problem with them. So the nice thing about this mat is that this mat does not use flow interruption. And I don't care what sluice it is. I don't care if it's ones with round circles in it. There has to be some kind of flow interruption to create either a spinning vortex or a round vortex or a vertical vortex. It doesn't matter. There has to be a flow interruption where that bed load gets kicked back up into it, and that's where you can have possible losses. This mat does not do that. This mat simply just takes those three loads and allows them to lift up slightly and fall back down. So on the backs, you have sort of a throwing action, and then it settles back down. The other thing, so you have a flat area and a flat area, and then you have a hump in the middle. The water speed is fast here, and it starts to slow as it hits this upper portion, and then it speeds up again. And what you'll see, what you'll notice on the wave mat is that right in here and just on the upside of that hump, we see probably about 50% more gold deposits on this side of the hump than we do on here. So we have a heavier gold deposit here because the water, you're getting that low pressure zone here, and the gold is falling out as it loses energy and starts to go over that hump, and then it speeds back down. It sort of lifts and falls. So that's the beautiful part about this mat. It doesn't cause a huge amount of turbulence on your bed load, and that's the very bottom load, and that's what we're trying to achieve here. It's also a very open mat, and the thing that blew me away on the testing and really surprised us on our testing is how easily this mat exchanged out the gangue or the non-gold material. Black sands, other sands, hematite, whatever you want to call it. How easily this mat actually exchanged out those materials, but yet still hold on to the fine gold. Now the gold that we used in this test that I'm going to show you coming up, all went through a 100 mesh classifier. So it's all sub 100 mesh, probably in the 100 to 200 mesh range. So that's what we used. I think I had like 13 grams with me that day, and I put like 1 or 2 grams, 2 or 3 grams in each run that we did. All right, so where can you use this mat? That's another question that's going to be used. A lot of people are going to say, can I use it in a stream sluice? Can I use it in a dredge? You need to spend the time on the website. We're putting up a huge amount of information, a huge amount of technical data on this mat. And it really is one of these mats. You're learning along with us on this mat. So what you need to do is, if you're going to use this mat, you need to play with your GPH and you need to play with the pitch. The same thing that we're going to show you today is what you need to be doing. We ran one of our sluices as high as a 22-degree pitch. Our goal, which we always do with our mats, is we go to extremes. We go to an extreme and we try and blow it out. And then we try and go to an extreme where it's too low. I don't think we actually reached that too low stage yesterday. But we did reach, what surprised me was the capture rate. Once we got this thing kind of tuned in, what really shocked me was the capture rate on this mat. I was expecting, a 70% on beach sand, something around there would have been acceptable. And I'm telling you, we were close to a 98, 99% capture rate by weight on this run. Granted, we weren't dumping shovelfuls of material in and that kind of stuff, but it still was surprising. And I'm going to show you these mats. I actually brought them home. I didn't clean them out on the last run, and I'm going to show you some close-ups on those mats too. So we got a lot of information to cover. Let me first draw a traditional riffle. So here's your traditional sluice box. You put in some kind of flow interruption. I don't care what it is, but there is some kind of flow interruption. So as the slurry comes down, it has to hit this, and then it has to go over this, and then continue travel. Well, don't forget that within this traveling system, you have 3 layers of material. You have your bed load, you have your sediment load, and then you have your dissolve load. And what's happening is the material, the heaviest material, is trying to settle down into that bed load. And when it hits this flow interruption, it all comes back up here and it gets remixed up in here. So now it has to go through that process all over again. Is how do we take this, and without disturbing this process in here too much, how do we do it? And what we learned is that, well, if we put a bulge or some type of shape like this, what ends up happening is all three loads stay within their load pattern. So your bed load, your sediment load, and your dissolve load all stay in that same pattern. But what ends up happening is these lines sort of, as they come up over here, they stay in this, but this water speed starts to slow down. So you have a minus here. As it hits here, you have a lower pressure zone on this, on the front of the hump. Then it's sort of, these lines sort of leave the mat. They sort of elevate here because they get thrown up a little bit, and you get a settling down over on this side over here. So that's sort of a simple way to look at this, that you have your three loads. You have your, again, you have your bed load, sediment load, and dissolve load. If they hit a traditional flow interruption, they have to go over that flow interruption into a low pressure zone, and hopefully they're going to be sorted by specific gravity. But when you actually take this situation and you actually get rid of the actual flow interruption and you throw it over this hump, the lines sort of space out a little bit. They sort of space out and they lift up. It's kind of like when you're driving down the road and you sort of go over a hump, your body gets light. The same thing happens here. So it sort of goes light. And who's going to fall back in the seat the first? Well, it's me, the fat guy. You know, the kids aren't going to fall. So the heaviest stuff is going to fall out down here first. And that's sort of the same principle, is that terminal velocity, settling velocity, and specific gravity is going to come into play down here. It also comes into play up here. But we sort of lift those loads and they fall back down. And that's where that separation takes place. And that's why, while we were watching the mats yesterday, we were really, really impressed about the mats. Were just like almost all pure gold. It was a really quick exchange process. Again, granted, we weren't dumping shovelfuls in, but it was interesting to watch this process take place, where it comes up and comes down, the deposits, and where they were falling the heaviest on this. Again, we saw the heaviest deposits just where this water felt some back pressure right in here, because if that's your wave mat, the water is traveling pretty quick here, and all of a sudden it starts to feel a little bit of back pressure right in here. The water speed starts to slow down here and here. And so this is where right in here and right in all through here is where we saw probably the heaviest deposits on this actual mat. Then as it came off this, it sort of went into that launch mode. We saw much fewer deposits right in here, and then it came down and we saw a lot of deposits back down in here. So it's interesting to understand how that works. So the water speed is constant until it has to go uphill. I mean, if you went steep enough, you could stop the water flow basically and have it backflow. So, and that's what we did, is we always use the extremes. So the water's coming along, it has to slow down to go up over that hill, and then it launches back. Again, I'm going to stress that there are two mats. The wave mat by itself has a flat area, a hump, and then a flat area. So you can use wave mat, wave mat, wave mat, wave mat all the way down if you want. Some people are going to be playing with a mother load, wave mat, because it's really good on, mother load's really good on fine gold and beach sands. The big wave mat is essentially a connection point and then a big hump and another connection point. So this is what the big wave mat looks like. And of course it has the capture zones in here as well too. So you need an area for that water to regain the speed. That's why when you use the big wave mat, you need to connect another mat here and another mat here. And that mat is either going to be UR or mother load, probably. Something that doesn't have a flow interruption in it. I would think, especially if you wanted to put a little bit of this at the end of maybe a dredge extension, man, that would be great. If you had a dredge extension, take your normal dredge and add an extension to it and run mother load and big wave mat off the end of your dredge. Whoa, man, you would see a ton of fine gold in there. So just remember, there's two mats, wave mat, big wave mat. Big wave mat is for much higher water, and we'll be playing with it and experimenting because, again, we're learning along with you on these mats and this technology. So let's go out to the video shoot. Okay, so what I'm going to do today is we've taken Alaska beach sands and we've seeded in sub 100 mesh gold, and I'm just going to record some footage for you real quick. So it's cold out here today, so we're just setting this thing up. I've actually got a hybrid. I've got a multi-sluice here with 1100 GPH. I've got an extreme pitch. I'll measure this in a minute. And then we reduce the pitch down over here, and we're going to seed in some gold and see how this goes. You can see the mat action, what it does. It rides over that hump. There's a little groove right here that creates a little bit of a vortex right there. You should probably see some decent gold in those. And that's it going all the way down. So this is a reduced flow, and this is that steep flow. All I'm going to do is I'm just going to feed in some of this Alaska beach sands here. All the gold in here is sub 100 mesh. And my goal at this point is to have everything just about blow out of this mat. And if I have everything blow out of this mat except for one thing, what's that one thing going to be? Well, you can see that there's gold already right up here. I don't know if you can see that or not. So I'm going to run some of this and then I'll shut it down. Okay, so I've just run a little bit of this, and we put a lot of gold. This probably has about a gram or two of sub 100 mesh gold. But here's what I want you to see. You can see up here, there's a couple lines of gold forming right up there. And then I'm trying to blow this mat completely out. I don't want anything to stay in this mat. If anything stays in this, it's going to be maybe a little bit of gold. But then look, once I change this pitch a little bit, look at these lines. I hope you can see that. There's lines of gold right there in that mat. Right behind that little riffle, there's a line of gold. Look at all the gold there. So as this water speed is slowing down, now we're starting to see some gold because it's dropping out. But you know what I'm not seeing? I'm not seeing a lot of black sand build up, and that's what I wanted to see. I come down here, I see less gold, but I still see gold all the way down the end. So I probably could actually decrease that pitch just a little bit. So up here at the very, very top, I've got gold. I don't have much gold in here. I have a little bit of gold coming down. And then as soon as I drop the pitch, man, I get a lot of gold, more gold, more gold. So this sluice right here is probably set at the right pitch for about an 1100 GPH pump. And don't forget, I got a lot of lift, so I'm probably only running about 700, 800 GPH to it, and this is 8 inches wide. I'm just making notes to myself. So let me get my phone and check my pitch. Okay. So I've got this set at roughly 21 degrees on this upper box, 21. Lower box is coming in right at about 10 degrees or 11 degrees. This is exactly what I'm talking about. What I want you to do with this mat is start it at an absolute extreme. So what you're going to do is start it at maybe, 15, 16 degrees, and then degree by degree by degree, you're going to lessen that pitch. Now I see almost nothing but gold in this mat. I see actually a tiny bit of gold right here. There's a little bit of gold up here. This is on the upper 21 degree pitch. And then when it drops down, look at it here. Look at all that gold in there. That's a lot of gold right there. But here's the thing, I'm not seeing really any black sand, so I probably need to drop this down just a little bit to get a little more black sand in here. Because I've got gold all the way down, so I know I've got gold on my tailings. So, but this is, I just wanted to demonstrate that if you run this thing super fast, this is the whole point to it. This is that just reducing the pressure. If you run this black sand super fast and you just bring it up a little bit enough where something's going to drop out of it, what's going to drop out of it? Usually it's going to be the gold that's dropping out of it. So we're going to play with it a little bit more. Pretty cool. Okay, so now we're going to change the pitch one more time. This one is roughly 11 or 12 degrees. This one is about 7 or 8 degree pitch. We're going to fire this up, and I'm just going to leave the gold in there. But you can see that almost all the way down I have no black sand whatsoever. There's just specks of gold here. There's nothing in here but gold in this one. So let's play with that. Okay, so we're running at the different pitch now. Again, we're feeding more of this black sand, but I wanted to show you it. I really wish I had about 1100 GPH true going into this, because just a little bit deeper water would be nice. But man, you can just see the lines of gold forming here. And now I can see sand actually down here being stuck in these down here. So these grooves now actually have some sand inside of them at about a 7 or 8. And these up here have almost no sand and gold in it, just like it, because we reversed it. So just so you know, while we're doing this, we are doing some of this. We assume through all this extreme testing we're going to have gold down here, but I just wanted to show you that we are doing some of this tailings test down here. Okay, so one of the things we've done out here is, and one of the things I want to show you is just how extreme this mat strips it down. You can run it. So I'm going to clean out. We're going to clean out this whole sluice system here after 2 runs, running pretty hot. And I'm going to wash it out, and I'm going to put everything that's in these mats that we just ran, a few gallons of black sands, beach sands through. I'm going to put everything in the mats into a pan, and I'm going to show you just how much was stripped down on this. Okay, so we'll clean out the mats. To give you a little perspective, there's about 2 or 3 tablespoons in here, and that's it. And then you can see, I just tapped it. You can see the gold in there. Well, that's pretty cool. Okay, so now what we're doing is we're slowing this way down. I've got the upper at 7 degrees, and I've got the lower at 4 degrees. And you can see I don't have quote-unquote sort of rooster tail action in this now. It's more of a smooth running mat. You can see how smooth she's running. And let's see, our goal is the same goal that you should have, is start blowing it out completely, inch it up, inch it up, inch it up to the point where you just start to see a little bit of sand or concentrates in the mat. You don't want to change the shape of the mat because concentrates are building up. You just want to see a little bit of sand in there. Okay, so now we're feeding it, and you can see how smooth this thing is running now. And you can see that we're actually having a pause. In other words, it's taking time for this to exchange out over the humps. This little groove here is sort of a little vortex, a little drop ramp. That is going to be a good spot to catch gold. But now you can see where I'm starting to have, now you can start to see where I've got material starting to build up in these little ramps, but they're active. I can see little pebbles bouncing around in there. So inside these little grooves, I can actually see exchange action happening. So I can see bouncing of material and bouncing of material inside each one of these little grooves. And that's what I want to see. So Doug, I'm going to have you pause for a minute, and let's see how far this cleans down, because I don't want this mat down here to clean out totally. Because what I want you to see is, I want you to see the action of that, like that little pebble right there. That little pebble is dancing inside that groove. It's still cleaning out pretty strong though, but it takes a while to clean out, and that's what I want to see. Again, you can see things bouncing around. But what's funny is, look up here. Look at how much gold is up here. Holy cow. Man alive. So, this is An 1100 GPH pump. I don't know if you can see this or not. This is an 1100 GPH pump that's got a high lift, so we're probably running about 800 GPH. I might like my GPH a little bit higher. But look at that. And that's up on the top. You can see the mat's pretty black, all the way black, 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 and then it goes to here. Look at it. Wow, that's impressive. Okay, go ahead and feed it some more. Now you can see down here, I'm really not seeing any gold down here at all. Do you see any, Mike? I mean, I'm not seeing any down here on this lower section. And we do have a pan down there, by the way. But watch what happens here. Watch this. This is insane. Come along, come along, come along. Look at that. Look at those gold lines up in there. Holy cow. Up under the header box. Look at the one up under the header box. Man, I gotta shut this off and shoot it. Let's shut her off. Holy cow. Okay, so you can see black mat, black mat, black mat, black mat, black mat, black mat, gold. Look at that. That's insane. That is absolutely insane. Look at that gold right there. All sub 100 mesh gold, 100 to probably 300 mesh gold, all in this wave mat. Using no flow interruption, using only variations in water velocity and slurry speed is basically what we're doing. But when we were doing our blowout test, we had gold all the way down here. But look at this mat, like right here. See the few specks there? There's a few tiny, tiny specks. But man, that's high. Wow. So surprisingly, you know, I keep repeating that this is not a high capture mat, especially when you're working beach sands and black sands, which that's not what I'm pushing it as. This is just something different. But when we set it up, again, this was up at about 7 degrees. This was pretty flat, like at a 4 degrees, 4 or 5 degrees. Here's what was in the tailings. We left this pan here the whole time, and there are my tailings right there. And I would say we're probably above a 95% capture rate, because look at this. Starting here, you can see a little bit of gold, but then look at this. Look at all that gold that's up in here. Look at all that. That's amazing. So I'm actually shocked at the percentage on this thing. It's pretty high, a lot higher than I thought. All right, so one of the things that I want to make a note about is how impressed I am with the lack of energy needed, I thought I was going to have to pitch this thing really, really high to strip it out and get rid of all that black sand. And what we found is that when we did that, it overstripped it. So I actually was able to drop it fairly low, and it still stripped out the black sand and held the gold. That's the shocking thing to me, is you don't need a whole bunch of energy on the regular wave mat to make this action happen. I want to get that note in here. Here's the point that I want to make on this. We're running this bottom sluice at 5 degrees, okay? And look, I haven't cleaned it out. You can see gold in there, but what you don't see? You don't see black sand. You see a little bit here, but not on these humps. And so what we're talking about is the fact that you don't need a lot of energy to clean the black sand out on this. That is really, really what impressed us on this, is the low energy amount, lack of turbulence to clean out the sand and to hold the gold. Really impressive. Okay, so I figured I'd shoot this real quick. This is the next day, but I brought the mats home from that last run and did not clean them out because I wanted to show you this. So I have number 1 mat, number 2 mat, 3 mat going down. This is where the flare, this is where the sections connect all the way down. This is the second mat down here. But here's what I wanted to show you. I wanted to give you sort of a close-up view of exactly what's going on here in the mats. So this is number 1 mat. You can see it's just loaded with gold. This is number 2 mat. And you can see that on the back side of this mat, we have less gold here than we do here because the water is slowing down, gold is dropping out, and then it's speeding up. In other words, it's a lift and it falls back down. There's number 3 mat. You can see the gold in there. This is number 4 mat, less gold. Number 5. Number 6. I'm going to call this number, I'm going to skip this. This is where the mats overlapped. This is number 7. Number 8. 9. 10. 11, and then 12, the last one. But if you look at number 11 here, there's almost no gold in this mat whatsoever. I really struggled to go through here and find any gold, any specks of gold in here. Pretty interesting. So I think this is a real good perspective to show what we were doing here. Here's the mat all the way down. And one thing I failed to mention is there is a little ramp here. So here's the hump. If you come back up the mat, there is sort of a little vortex sort of ramp here. And I'm going to go in close and I'm going to shoot some video close-up of these different ramps so you can see that that's more of a traditional style riffle or flow interruption or area that you might see in a sluice, and you can see all the black sands and non-gold material in there. So I'm going to get my camera and go close in with this. All right, I'm shooting this on my phone with my zoom lens, and there's the first ramp. Then you go over the hump, and let's look at this other ramp here. And now you can start to see as the water slows down, you can see non-gold material inside that ramp there. I'm going to skip down to, oh, let's go over down to almost some of the last mats. Versus the ramp, and here's the ramp on the last mat. You can see that there's almost no gold in here. There's the ramp. Here's the hump. And let's go back up here to the primary hump. This is the first mat. You can see that little chamber there. Pretty cool. Anyways, guys, hope this was information. If you have any questions, don't forget, go to the Wave Mat page, and we'll be structuring that out. Go to the website, look for the Wave Mat little logo, click on that, and you can see links to all the technical information, the spec information. Click that subscribe button. There's a little subscribe button down there. Click that subscribe button. 2 reasons. Number 1, it'll notify you. You'll get notified when we put up more videos on this and testing on it. And the other thing is, this year we are going to be doing a giveaway, a real big giveaway to one of our YouTube subscribers. So make sure you subscribe to that. Talk to you later. Doc.